Hello, this is Mrs. Grosch, and the topic for today's lecture is seeing stars. If you remember what you've already learned about stars, you know that they're really giant balls of gas. And in those giant balls of gas, there's a reaction going on. It's called nuclear fusion, and it releases lots and lots of energy. The energy that stars release comes in many forms. Light energy makes it so that we can see the stars, and heat energy makes it so that we can feel the energy from the sun. But there are other forms of energy that are released by stars. All of the energy that is released by stars comes in a family. They're all forms of electromagnetic energy. Some of these types of energy go right through our atmosphere, and so we can experience them, and they have an effect on our bodies. Other forms of electromagnetic energy are blocked by our atmosphere, and that's actually a good thing for us because some of them are very dangerous. These different types of electromagnetic energy all have some things in common. For example, they all travel with a pattern that we call a wave. And they all travel in straight lines. They all travel very fast. Through the vacuum of space, their speed is what we refer to as the speed of light, which is 186,000 miles per second. One of the main ways that these different forms of electromagnetic energy are different is how big their wave is. So there's a couple different wave measurements that you should be familiar with. If you look at this picture of the wave, you can see that there are high points and low points on the wave. From the crest, which is the high point of one wave, to the crest or high point of the next wave is a distance that we call the wavelength. There's another measurement that we use, which is frequency, and that is how many full waves pass by a certain point in 1 second. So wavelength and frequency are important measurements in understanding how these different types of waves differ from each other. If we put all the different types of electromagnetic energy on a number line according to their wavelength and according to their frequency, we would have what's called an electromagnetic spectrum. It's just all those types of energy put into order, so that their measurements go from longest to shortest in the terms of wavelength, or from lowest to highest in terms of frequency. When you measure wavelength and frequency, sometimes you have very large numbers and sometimes you have very small numbers. One thing that you can notice about the spectrum is that longer wavelengths have lower frequency, and waves that have those long wavelengths and low frequency tend to be less dangerous. On the other hand, waves that have short wavelengths have much higher frequency, and those tend to be much more dangerous. So the least dangerous types of waves are the radio waves. They are very long with very low frequency, and the most dangerous waves tend to be the gamma rays. Those can be very dangerous to our bodies. They have very short wavelengths and very high frequencies. The reason that we study the electromagnetic spectrum as part of our astronomy unit is because different telescopes collect those different types of electromagnetic energy, and so they can see the stars in different ways. Some telescopes collect light energy. Those are the types that you might use if you have a telescope at your house. But other telescopes collect radio waves or microwaves or gamma rays. There's all different ways of seeing the stars. And that's why this lecture is called Seeing Stars. I hope you found this interesting. Thanks for listening. I'll see you in class tomorrow.